All right. Day 13. Distress signal. You climb the hill and again try contacting the elves. However, you instead receive a signal you weren't expecting, a distress signal. Your handheld device must still not be working properly. The packets from the distress signal got decoded out of order. You'll need to reorder the list of received packets, which is your puzzle input, to decode the message. Your list consists of pairs of packets. Pairs are separated by a blank line. You need to identify how many pairs of packets are in the right order. And then we have a whole bunch of pairs of packets here. Okay. Packet data consists of lists and integers. Each list starts with an open bracket, ends with close bracket, and contains 0 or more comma-separated values, either integers or other lists. Each packet is always a list and appears on its own line. When comparing two values, the first value is called left and the second value is called right. And then, if both values are integers, the lower integer should come first. If the left integer is lower than the right integer, the inputs are in the right order. If the left integer is higher than the right integer, the inputs are not in the right order. Otherwise, the inputs are the same integer. Continue checking the next part of the input. If both values are lists, compare the first value of each list, then the second value, and so on and so on. If the left list runs out of items first, they're in the right order. If the right does, then we're not in the right order. If they're the same length and no comparison makes a decision about the order, continue checking the next part of the input. If exactly one value is an integer, convert the integer to a list which contains that integer as its only value. Then retry the comparison. For example, if comparing a list with three zeros and the single integer 2, convert the right value to a list containing 2, and the result is then found by instead comparing the list of zeros and 2. Using these rules, you can determine which of the pairs in the example are in the right order. And yeah, then we go through each of the pairs. We have these two where we compare 1 and 1, 1 and 1, and then we get to 3 and 5, and finally we can determine that the left side is smaller, so they are in the right order. Pair number 2, start by comparing these, they're the same. Then we compare these, and so first we turn this one into a list, and then we retry, and we determine that 2 is lower than 4, so they are in the right order. Then we have 9 versus a list with a list of 876, and 9 is, so we convert 9 to a list, try again, and then we find that left side is smaller. No, left side is greater than, so they are not in the right order. There's a whole bunch of 4s. Left side runs out of items first, so they're in the right order, and so on and so on and so on and so on. Okay, so what are the indices of the pairs that are already in the right order? The first pair has index 1, the second has index 2, and so on. Okay, so they are 1 indexed. That's good to know. In the above example, the pairs in the right order are 1, 2, 4, and 6. The sum of these indices is 13. Yeah, and once again, struggled to read. So it took me a long time to get all these different rules into the code. So I think maybe if we look at, I'm going to get rid of that, and then we're going to do this. Cool. Okay. So to implement all these different rules there, I create a function called R in order. It says that they're always lists, so we compare the lists, compare them as lists. So we have a variable I, which index we use as the index into the two lists. And if the left side has run out, then we're good. Then we say yes, according to this rule right here. If the left side runs out first, let's see if we can make this a little smaller. Hope you can still read it. Okay, if the right side runs out, then we return false. Yep, if the right list runs out of items first, then they're not in the right order. Okay, so once we've determined that we are not past the end of either of them, we get the value left and right. If they are both integers, then if the right is less than left, then it's false, and vice versa. That's the rule we have right here. If the left integer is higher, then they are not in the right order, and so on and so on. All right. If instead they are both lists, then we just recursively call this function rnorder, and we store that value. And if we get to the end of an array, or sorry, a list, and we haven't yet determined which one is the winner, we return none. I'm basically assuming that we will never end up with two inputs that are indeterminate. So I assume that all the input that we are provided with has an ordering that is deterministic. Yeah, I guess deterministic. Anyway, yeah, but if we finish looking at one of these nested lists and we don't know which one is the winner, then we just keep going. All right. Finally, if they are not both integers or both lists, then we turn whichever one is an integer into a list, and we do the same thing. We try to see if we can determine the ordering. If we cannot, then we fall through, and then we go then this for loop goes on to the next one. And if we can determine the ordering, then we return whether it's in order or not. So, yep. So part A really becomes just loading all the lines. We set a counter. Then I use this here to jump 3 lines at a time. And then I have the left and the right. I just use the Python eval function because this just happens to be how Python would represent these exact values. So it's just a matter of interpreting this as though it were Python. So that gives me left and right. And if they are in order, I increment the counter by, yeah. So it is the I value gives us the line number, but we need the counter tracks the pairs. So all these two here are pair number 1, and these two are pair number 2, etc., etc. So I will be 0 at first. So I take I divided by 3 plus 1. That gives me 1. And on the next go, I is going to be 3, and so I take 3 divided by 3 and add 1, and that gives me 2, and so on and so on. So this gives me the index of the pair, and add that to the counter, and that gives me the answer. All right. So, yep, I think that's all there is to say about part A. Part 2. Okay, now you just need to put all of the packets in the right order. Disregard the blank lines in your list of received packets. The distress signal protocol also compares... No. also requires that you include 2 additional divider packets. So, and they look like this. So double nested 2, double nested 6. So a list of the value 2, and same for 6. So using the same rules as before, organize all the packets. So all the ones that are in the input, as well as these 2 divider ones, and order them according to the rules above. So, yep. And then what we just got to do is we need to find out where 2 and 6 land, and multiply them, and that gives us the answer. So that is what we have over here. Part B. So we look at I make a list of all the different elements. I add the 2 and 6 as per the instructions. Then what do I do then? Right, so I just copied the where is it? There, the for loop from part A. This is stupid. For ln lines, this is better. If L is empty, then we just continue. Otherwise, we add the line. That still gives me the right answer, doesn't it? It doesn't. I shouldn't have done that. Are in order if range left has no len. Oh yeah. Like that. Yep. Yep. Okay. So I skip over the empty lines, and otherwise whatever is there I add to my elements list. Okay. So sorted is a Python function that sorts a list according to, well, by default, it just compares them. But we can't directly, I mean, we can't just Python can't by default just compare these, you know, as we want them to, because there are all these special rules. But the sorted function wants a key. It doesn't want a comparator function. So luckily we have in functools, there is something called CMP to key, which basically turns a compare function into a key. So I had to create a function that would return -1 if they were in one order, and +1 if they were in the other order, and, well, 0 if they're the same. But I didn't have to worry about that because, well, they all have, there is a given order that is correct. So yeah, that gives me the ordered elements. And then it's just a matter of here. So ordered is the ordered lists of all the lines from our input, and then ordered.index 2 is going to give us the index for this, you know, what do they call them? Divider packets. And ordered.index, and the same for 6 is going to give us this one, and then we add 1 to each of them because they're 1 indexed, and multiply them, and boom, that was it. So part B was a lot more straightforward than part A. I come to the same conclusion every day, that I should slow down, I should read all the rules and everything and just implement it as it says. And then I would have gotten there a lot sooner. Slow and steady wins the race, right? But I'm not good at that. Patience is not my strong suit. But, yep, that's it. That is day 13, and we're done. All right. If you have any questions or comments, leave them below, like and subscribe, and I'll see you tomorrow.